In this lesson, we will solve for x by finding when the rational expression is 0. We interpret the instruction as solve the equation open parenthesis x squared plus x plus 1 close parenthesis over open parenthesis x to the fourth plus 1 close parenthesis equals 0. Key idea: a fraction equals 0 exactly when the numerator equals 0, while the denominator is not 0. So we will set the numerator equal to 0, and also remember to keep the denominator non-zero. First, let's think about real solutions. Look at the numerator x squared plus x plus 1. Complete the square to see its minimum value. It becomes open parenthesis x plus 1/2 close parenthesis squared plus 3/4, which is always at least 3/4, and therefore always positive for real x. Since the denominator x to the fourth plus 1 is always positive, the whole fraction is always positive and can never be 0 for any real x. If complex solutions are allowed, we solve the numerator equation exactly. Using the quadratic formula on x squared plus x plus 1 equals 0, the discriminant is 1 minus 4, which is negative 3. So the solutions are x equals negative 1 plus or minus I times square root of 3 all over 2. These are the primitive third roots of unity. We must also make sure the denominator is not 0 at those x values. The equation x to the fourth plus 1 equals 0 has solutions where x to the fourth equals negative 1, which are the fourth roots of negative 1. Our solutions negative 1 plus or minus I times square root of 3 over 2 are not any of those fourth roots, so the denominator is non-zero there. To build real number intuition, let's graph the function y equals open parenthesis x squared plus x plus 1 close parenthesis over open parenthesis x to the fourth plus 1 close parenthesis over the real x-axis. Notice it stays above y equals 0 for all real x and approaches 0 as x grows large. Summary: over the real numbers, there is no solution because the expression is always positive. Over the complex numbers, the solutions are x equals negative 1 plus or minus I times square root of 3 over 2.